Hi guys, this video is for pre-cal and it comes from 9.3 and it is on parabolas. So you may have learned about parabolas throughout middle school and algebra 1 and 2, and you may be used to just seeing x squared facing up or down, whether it's positive or negative. We're going to go into some more detail, not only facing up and down when the x is squared, but right and left when the y is squared. We're also going to focus on more details on the parabola, like the width, where the focus is located at, and then the axis of symmetry and this line called the directrix, okay? So let's start off by the formulas. We have a vertical parabola when the x is squared, and then notice we have the h and the k like we've been seeing with our past shapes. That's going to dictate where the vertex is, okay? So kind of like the center. Notice that only the parentheses on the x is squared. And then notice we have this number of 4p. I'll get into more detail on that in just a minute, okay? Horizontally, we have the h and the k with the x and the y, but the squared is on the y and the 4p is over here with the x. And this faces to the right if it's positive and to the left if it's negative. Now, the focus is going to have a specific distance towards the inside of the parabola. Picture like the belly button of the parabola, okay? Now, the distance to that focus is found by solving for p. In our equations, we're going to have an actual number here. Let's say if the number was 8, then p would be 2, because you divide by 4 to find that. And then we'd go 2 units inside the parabola to find the focus. And then you would go 2 units back to find this directrix. Now, this directrix is just like an asymptote almost behind the parabola, okay? The way I tell my class is directrix is like your derriere. It is behind you, okay? It is behind the parabola, okay? That works the same for horizontal parabolas, okay? Again, if this number were to be 8, and I know that my y is squared and this is positive, it's facing to the right, the p would be 2, and I just go 2 units inside the parabola for the focus, and 2 units back to draw this equation of a line, which is my directrix, behind the parabola. Okay, an axis of symmetry is just the line that splits the parabola perfectly in half, touching through the focus. Okay, so down here some notes we have the vertex is h comma k, p is the distance to the focus and the directrix. Okay, so the focus, depending on whether it is horizontal or vertical, we're adding that distance p to either the h or to the k. The directrix, we're subtracting it either from the h or for the k to go backwards, okay? Now, the parabola, if p is positive, so if these numbers are positive, the parabola either faces to the right or up, and if it's negative, it faces left and down. Now, something new you may not have learned about in Algebra 2, okay? It's got a pretty funny name. It's called the Latest Rectum. So you don't have to hear me say rectum 100 times in this video. We're going to call this the LR. Now, the LR is this complete number here, okay? So whatever number is there without dividing the 4 to find the p, so let's say we had said the number was 8. 8 is going to be the distance across the parabola located at the focus, okay? So if this number was 8, I'd go to where the focus is, and if this distance is going to be 8, then I'd go 4 to the right and 4 to the left, okay? Now, let's talk about why that's important for a second. I want you to think if you've ever seen like a satellite dish sitting, on top of a company's building or on top of a house. The focus is where the antenna needs to be. I don't know if you've ever seen a windy day, that antenna scoots off a little bit and you lose internet, right? So the location, the spot of that focus is so important. Now, the latest rectum is important because that satellite dish has a specific width with respect to the location of the antenna, so that when it gets, the signal, it can perfectly bounce off. Lastly, I just want to reiterate and show you, we had said if the x is squared and my 4p is positive, this is facing up, like a positive x squared that you've learned in the past. An x squared with a negative 4p faces down. Notice the directrix is always behind the parabola and the focus is always on the inside of the parabola. If I have a y squared that is positive, it's going to face towards the positive values. So it faces to the right a y squared with a negative 4p faces to the left. And again, both times the focus is in the inside like a belly button and the directrix is behind. Looking at this first question, I have x squared equals negative 4y. So initially I see an x squared and I see a negative, so I automatically know that this is going to open downward. Okay? I do not see numbers being subtracted or added after the x and the y, so I can say that my h and k are 0 and my vertex is at 0, 0. Okay? Now, p, I need to take this number in here and divide it by 4. So if that number, which is my LR, is 4, remember the negative is just to dictate that it's going downward, okay? Then I need to divide that number by 4 because the formula has a 4p to solve for p, which means that my p is 1. Okay, so let's go drawing what we know already. I said that my vertex is centered here at 0, 0. Okay, and it's going to open downward. That means if I'm going P 1 unit towards my foci, my focus, I'm sorry, there's only one, I'm going down here to negative 1 and drawing my focus. And then I'm going 1 unit back to draw my directrix. Okay, now my parabola is going to go downward, but I'm not going to draw it until I analyze my LR. Okay, so focus I can already see is down here at 0, negative 1. And my directrix is an equation of a line up here at y equals positive 1. So if my LR is 4, that means I'm going to go 2 units to the right and 2 units to the left. And that is going to dictate the width of this parabola facing downward. And you're done. Let's go ahead and look at another one. The equation reads y squared equals negative 12x. So I have a negative and I have a y squared, so I know that this is going to open to the left. Again, I do not have numbers being added or subtracted to the x and the y, so my h and k, my vertex, is 0, 0. This number here is a 12, which is going to be my LR. And I know in order to solve for that P, I have to divide that number by 4. Okay? So let's start by placing our vertex at 0, 0. It's going to open to the left, so my foci is going to be 3 units inside. And that's going to land at negative 3, 0. And then my directrix is going to go 3 units back. Okay, so directrix is an equation of a line at x equals 3. Lastly, if my LR is 12, that means the distance of this parabola located at the foci is going to be 12 units long. So that means I'm going to go 6 up and 6 down. So this is a very wide parabola. Okay, and again, this is at the location of the foci. And we are done with this one. All right, I have 3 more examples for you. Let's let them get a little more difficult, okay? I see that my x is squared and this is positive, so it's going to open upward, okay? My h and my k, I see numbers being added or subtracted to my x and my y. So my h is the number with the x opposite the sign, and my k is the number with the y opposite the sign. So my vertex is at 3, negative 1. Okay? Now, 8 is my LR, and if I divide that number by 4, I get my P, my distance to my foci and to my directrix. So remember, if this opens up from my vertex, I'm going to go 2 units, so 0 and then positive 1 for my foci, and then 2 units back for my directrix. So my directrix is an equation of a line at y equals -3, and my foci is a dot, an ordered pair at 3, positive 1. Lastly, at the location of my foci, my LR should be a length of 8. So I'm going to go 4 to the right, 1, 2, 3, 4, and 4 to the left, 1, 2, 3, 4. Okay, and that dictates the width. Whoop, open up a little bit more. There we go. Of my parabola. For this next question, I can clearly see that it is not in standard form. Okay, so let's take it back a minute. In the past few videos, when it is not in standard form, we have to rearrange things in order to complete the square. In the past questions, we had both an x squared and a y squared. We kept anything with those variables on the left, and any constants we scooted over to the right. In this case, because only x carries the squared, we only can complete the square to the x, and everything else must move to the opposite side. Whether it be the left or the right, it doesn't matter. So my first step that I'm going to do is move this 14 to the left so only the x's stay on the right. So I'm going to say 8y plus 14 equals 2x squared minus 12x. And I'm going to be putting that blank, and if I put one on one side, I must put it on the other. Okay, because again, I'm going to be completing the square with the x's. Now, a personal preference, the fact that I see that all of these numbers are even, 8, 14, 2, and 12, you have the luxury, if you'd like, to divide everything by 2 to work with smaller numbers. See that? Always allowed. So now let's go ahead. Remember, the x squared is the only one we can complete the squared with. So I'm going to be doing half of the middle term squared to go into that third spot. And then whatever I put in this third spot, I've got to do it to the other side, okay? If you want to rearrange and put all of these on this left side and all of these on this left, you're allowed to do that as well. So half of a -6 is a -3. -3 squared is a 9. If I add a 9 to one side, I must do it to the other, okay? So now I'm left with 4y, 7 and 9 makes 16. And then here, remember, I can rewrite this and put the x, put the squared on the outside, and then only half of the middle term, which be a -3. So far, my right side is starting to look really good, okay? Now my left side, if I want to see just the y with a number, I'm going to divide out whatever coefficient is in front of that y. So I'm going to say 4, and then y plus 4 equals x minus 3 squared. This should start to look a lot more familiar. If you feel more comfortable switching the order, you can say x minus 3 squared equals 4. I'm literally just mirroring it, okay? Y plus 4. Now, at this point, you're ready to graph. I can easily see that my x is the 1 squared and my 4 is positive, so this is going to open upward. My vertex is the numbers after the x and y opposite the sign. So I have a 3, -4. 1, 2, 3. 1, 2, 3, 4. There's my vertex. Okay, my LR is a 4, which means to find my P, I just need to divide that number by 4. So if this is facing upward, I'm going to go 1 unit up for my foci and 1 down for my directrix. So I can see that my foci is located at 3, -3. My directrix is an equation of a line at y equals -5. And then if my LR is 4 at the location of the foci, that's going to be my distance across. So I'm going to go 2 to the right and 2 to the left. Again, at the location of the foci. And that is going to dictate the width of my parabola. And you're done. All right, guys, last question. So the fact that I only see a y squared, only one of the variables squared, I know that this is a parabola. So since y is the one that's squared, I'm going to keep my y's on one side and move everything else over. Remember, my goal is to complete the square with the y, so I'm already going to leave my blank. I'm going to move that 16 over, the 25 over, and if I put a blank on the left side, I have to put it on the right side. I don't see a number that I can divide out of all of the terms because the coefficient on the y is just a 1. So completing the square here, half of the middle term, half of a -6 is a -3. -3 squared is a 9. If I add the 9 to one side, I must add it to the other. Okay? Now here, I can put the y in the inside, the squared on the outside, and half of the middle term would be a -3. Here, I want to combine my -25 with a +9, and I get a -16. Last step, divide this coefficient so that I can see my x like I see my y. And I get x plus 1. All right, it's ready to go. I'm ready to graph this. I can see that my y is squared and this is a negative, so this is going to open up to the left. My vertex, be careful when it's backwards. It's the number with the x and the y opposite the sign. So I have -1, 3. 16 is my LR. Again, the negative is just to dictate which way it's facing. If I divide that 16 by 4, I get my P, my distance to my foci, and to my directrix. So now because this is facing to the left, here's my vertex, I'm going to go 4 units to find my focus, and then 4 units back to find my directrix, my equation of a line. So my focus is at -5, 3. And my directrix is an equation of a line at x equals 3. Last step is my LR is 16, okay? So I need to do half of 16 up and half of 16 down. So located at this foci, I'm going to go 8 units up. And again, located at the foci, 8 units down. And that is the width of the parabola. It's a funny looking parabola, but it's a parabola nonetheless.